I welcome you to this YouTube channel. My name is your teacher, Science Joseph. Today I've brought you another video on oxidation, reduction, and redox reactions. I'm just summarizing it in a simple way. So watch this video to the end. Remember to subscribe and also like the video. Let's dive into the lesson for today. We are starting with oxidation, then we shall discuss reduction, and finally we shall discuss redox reactions. Now, you should understand that when we are dealing with oxidation or reduction, we define each of those terms using either in terms of oxygen or oxidation in terms of hydrogen or oxidation in terms of electrons or oxidation in terms of oxidation state or oxidation number. Let's dive into what does the word oxidation mean in terms of oxygen. Oxidation comes from the word oxidize or to add oxygen. So oxidation in terms of oxygen is the addition of oxygen to an element or a substance. So oxidation is the addition of oxygen to an element or a substance. For example, if you look at a reaction between magnesium and oxygen, magnesium plus oxygen, we receive magnesium oxide. In this case, we say that magnesium has been oxidized. Even we can have a similar reaction, magnesium reacting with steam. Steam is water vapor, so I've put a gas. So still, we can say here, steam has oxidized magnesium to magnesium oxide. So addition of oxygen is actually oxidation to a substance or an element. Let's look at in terms of hydrogen. What is oxidation in terms of hydrogen? Oxidation is removal of hydrogen. So removal of hydrogen is actually, we are carrying out what we call oxidation. We can have a reaction between ammonia. I hope ammonia is this formula, plus this is ammonia gas, then plus copper 2 oxide, copper 2 oxide, we shall actually get copper metal plus nitrogen plus water. So you can balance with the 2-3. You can balance in any way that you can easily. You can watch my videos on how to balance chemical equations. Now by seeing this reaction, we see that ammonia has lost hydrogen. In short, ammonia has been oxidized to nitrogen, while something has happened to copper 2 oxide, which we shall discuss later. So removal of hydrogen from ammonia to make it nitrogen, we have actually oxidized ammonia. So oxidation is removal of hydrogen from a substance, which can be a molecule or can be a compound. So let's dive into oxidation in terms of electrons first. In terms of electrons, let me use this simple illustration here of a reaction between between zinc granules and copper 2 sulfate plus copper 2 sulfate to give us zinc sulfate plus copper metal. So when we observe this reaction, zinc has actually displaced copper, because zinc is more reactive than copper, to form zinc sulfate and copper. But we can learn that if we broke down this reaction into anionic equation, we can be able to understand what we are meaning by in terms of electrons. Allow me to rub off this and we delve into the ionic equation between copper sulfate and zinc metal. So you'll go and watch my video on how to write the ionic equations, but by observing this reaction on how to write ionic equations and learn how I've broken this equation into an ionic equation. Now, if we picked out, let's try to pick out only zinc here. Zinc will have turned into zinc 2 ions, and you are aware that to form an ion such as a positive ion, it involves loss of electrons. Now, mathematically, we would have written something like this: minus 2 electrons to give us zinc ions. So it means that we've transferred these electrons on this side, so we can write that equation for zinc as plus 2 electron this side, because you can't form an ion without engaging in electron loss if it's a positive ion. Now we can see that zinc atom lost 2 electrons to form zinc ion. This is called oxidation. That is in terms of electrons. If we broke copper 2, we can see that copper this side has actually changed into copper, but we shall talk about that under reduction. That oxidation and reduction are always occurring in the same reaction, so you can't work isolated one from the other. So this is oxidation in terms of loss of electrons, which I just transferred the other side. Let's look at oxidation in terms of what we call oxidation number. Oxidation in terms of oxidation number, that's part D, terms of oxidation number or oxidation state. Now, oxidation state is just the charge on the element or the atom. We can see zinc here has no charge, so it has oxidation state 0, whereas zinc ion here has oxidation state plus 2. So the oxidation state has increased from 0 to 2. So in terms of oxidation number, oxidation is the increase in the oxidation number of an element or the ion. So increase in the oxidation number or oxidation state of an element or the ion is called oxidation. Let's dive into a discussion called the reduction reaction. What is actually reduction? We are also going to define reduction in terms of electrons. We define reduction in terms of hydrogen. We define reduction in terms of electron. We define reduction in terms of oxidation state. Let's dive into in terms of oxygen. So reduction is actually to remove oxygens. This is the removal of oxygen from an element or a substance. Let's look at an example here. A reaction between copper 2 oxide plus hydrogen gas, we actually get copper plus water. We realize that copper here has lost oxygen and has become copper. So loss of oxygen is called oxidation. Loss of oxygen is called reduction, and removal of oxygen is called reduction. So that's how you define in terms of oxygen. There are many other reactions which you can show that an element or that substance has lost oxygen. So let's define in terms of hydrogen. We can use the same reaction up here to understand that. In terms of hydrogen, it means reduction is addition of hydrogen. Addition of hydrogen to a substance. Hydrogen to a substance. So in this same reaction up here, you can see that when I add hydrogen to copper 2 oxide, I actually make copper 2 oxide to lose oxygen. So addition of hydrogen causes what we call reduction. I'm reducing copper 2 oxide by addition of hydrogen. So the same reaction can be defined in terms of oxygen and hydrogen. Let's dive into the third definition. How do you define reduction in terms of electrons? Let's use the reaction we just used the formula here. Reduction in terms of electrons. That is part C. How do you define reduction in terms of electrons. Let's have this same equation. Zinc displacing copper to give us zinc sulfate plus copper solid. So ionically, you look at my videos on how to write ionic equations. I've fully explained them there. So we arrive at that. If we remove zinc here, zinc would actually be written like this, minus 2 electrons to form an ion. We have to have lost electrons. So mathematically we take the electrons the other side. So it appears this way. Because science is beautiful, so this looks more beautiful. So we can have copper 2 ions. Now copper 2 ions, to become the copper atom again, we must give it electrons. So if it lost, first give it electrons, then it will become a neutral atom. So this here, copper 2 ions have gained electrons to form copper metal. In other words, copper 2 ions have been reduced by gaining electrons. So in terms of electrons, reduction is gain of electrons. Reduction is gain of electrons. Let's look at the same reaction using what we call oxidation state in terms of oxidation state. Oxidation state. Now oxidation state, we said it's just the charge on the atom or the element. Here copper has a charge of +2, so oxidation state is +2. Whereas this copper atom here has no charge. So we see that the charge has reduced from +2 to 0. So reduction in the oxidation state is actually what we call reduction. So reduction in terms of oxidation state, it is the decrease in the oxidation state or oxidation number. Allow me dive into the last part of this discussion called redox reactions. But before I look at redox reactions, let me summarize something for you here called a mnemonic to remember oxidation and reduction in terms of electrons. We have a mnemonic called the oil ring. This stands for oxidation. Let me start here. This is oxidation. So this down is oxidation. This stands for is loss of electrons. Then this stands for reduction, is gain of electrons. Gain of electrons. So you can remember in terms of electrons that oxidation is loss of electrons, while reduction is gain of electrons. But let's again talk about a redox reaction. Then in there we shall talk about reducing agent and oxidizing agent. What is a redox reaction? We said that despite us discussing oxidation and reduction separately, it does not mean that the two work isolated. Reduction and oxidation can never work isolated from each other. Every reaction that involves the oxidation has a reduction in it. So we can take this example of this reaction, then we can give a definition. Consider the same reaction, zinc reacting with copper 2 sulfate. So I'm using ionic equation. You get zinc ions plus copper metal. So this is zinc granules added to copper 2 sulfate solution to give us zinc sulfate solution and copper metal. So if we try to look at the oxidation states, you can view this reaction and see that the oxidation state is 0 here, has increased to +2 for here. Here the oxidation state is +2, has reduced to 0. So you can see that one reaction is an oxidation reaction and the other one is a reduction reaction. So this typical equation is an illustration of what we call a redox reaction. So a redox reaction is a reaction in which both oxidation and reduction occur simultaneously or occur at the same time. So we have said that there is no oxidation reaction that can occur on its own, and there is no reduction reaction that can occur on its own. They're always in combination. So we can view another reaction here, copper 2 oxide reacting with hydrogen gas to give us copper metal plus water. By looking through this reaction, we can realize that copper has been reduced. Why? Copper 2 oxide has been reduced to copper solid by removing oxygen, whereas hydrogen has been oxidized by gaining oxygen. Because oxidation is gain of oxygen, this is oxidation, this is reduction. So this is reduction, so this is oxidation. Let's tap into another reaction here and we really find out what has happened. Let me put here longer reaction, manganate ions. I'm putting 2 key reactions for brainstorming, plus iron 2 ions, I'm balancing it as I write it, plus 8 hydrogen ions gives us manganese 2 ions, plus 5 iron 3 ions, then plus 4 water molecules. So we can decide this is an example of a redox reaction, but who has been oxidized, who has been reduced? Look at iron. So iron, the oxidation state is 2 here. It has gone to it has gone to plus 3. So iron has been oxidized from iron 2 to iron 3 ions. What has happened to the manganate ions? Hydrogen ions normally act as a medium. We know protons are actually representing an acid. Water is actually one of the products formed in a reaction, but the key components for oxidation and reduction is iron and manganate ions. So what has happened to this? The oxidation state is plus 2. Now here we must calculate the oxidation state using the knowledge of oxidation states. I told you that you let for manganese be X. So manganese oxidation state is X. Let's add for oxygen times each oxygen has -2 equal -1. You realize that you get plus 7 here. So manganese has an oxidation state of plus 7, meaning that the oxidation state has been reduced here. So manganese 7 ions have been reduced to manganese 2 ions, whereas the iron 2 ions have been oxidized. This is a typical redox reaction. Ponder about this reaction. Potassium iodide being added, let me use potassium iodide being added to bromine. So we shall get potassium bromide plus iodine. Now, what has really happened here? To understand very well who has undergone oxidation and reduction, it's always wise to look at the ionic equations. They better represent for you the charges. So, can break down into ionic equation. This will be 2 iodide ions ionically. Try to look at my video on how to build ionic equations. Pretty easy. This will be bromine molecule. Then actually we shall get, let me use bromine gas being bubbled through there. That would be meaningful. So we shall get bromide ions ionically here, then plus iodine solid here. So we see that the charge on iodine is -1, oxidation state is -1, oxidation state on iodine is 0, oxidation state on bromine is 0, oxidation state on the bromide ion is 1. So we see that -1 has increased to 0. So potassium iodide has been oxidized to iodine, whereas the bromine has been reduced to bromide ions. There are so many reactions. Don't mistake, there are some reactions such as neutralization reactions here which cannot be oxidation. Rather, it is just exchanging parts of the molecule. So we shall get here sodium chloride plus water. Now if you check the oxidation state ionically here, sodium will still have positive 1 and positive 1. Nothing has happened, no change in the oxidation state. You look at the oxidation state of maybe a chloride, you compare it with another chloride. You can compare a few parts of that and you realize that there is no change in the oxidation state at all. So always try to look at the ionic part of the equation to come up with better understanding of whether it's a redox or not.